Welcome to another episode of I Am Nano.
Putting the I in I Am Nano. I am your host, Irfani.
And I am your other host, Monica.
And I'm quite excited about today's episode. Okay, so I've been watching a lot of Marvel movies recently, and especially, with WandaVision, as well as The Falcon and Winter Soldier. It's given that they're really great movies and TV shows. But the other thing that's amazing is their vision of future technology. And in particular, the Iron Man suit seen in Infinity War, the Mark 50. Tony pulled on the string on his suit and then tapped on his arc reactor. And then all of a sudden, these nanoparticles just swarm his body, and then the armor appears.
Yeah, that was so cool. But
Yeah.
realistically, though, not to be a party pooper, but as cool and as well done as the movies are, 2021's nanotechnology isn't quite there just yet.
Yeah, I know, unfortunately. But anyways, I was really curious about it and then spent some time, on the internet reading. There's a lot of parameters involved that must be designed properly to make the suit. So, for example, the nanoparticle machines that some people have referred to as nanobots, they must be synthesized directly on the armor on the body that Tony wears. And then the nanoparticles are programmed to follow a certain skeletal structure. And then once assembled, it must have advanced insulation and be able to operate as intended. And not to mention the power source that's required for all this assembly and operation of the suit.
Yeah, exactly. And the current state of nanotechnology is not completely there yet to make this advanced form of suit. For sure, though, lots of exciting research to be done in this area, though.
Yeah. So we scoured around scientific literatures to see if there are any recent works done that may give us, some hope and a step forward towards the suit, particularly its ability to assemble in a certain structure. It was kind of hard to find ones that exactly illustrate how the suit is fabricated, but there was an interesting one by Sun and colleagues from a collaboration between Xi'an Jiantong and Columbia University, who were able to program nanoparticle clusters or architectures by developing a DNA mesh frame scaffold that are programmed to have different valence modes where the nanoparticles can attach to. And this technique is designed to mimic atomic valence that determines atomic structures.
Oh, wow. That sounds very, very interesting. Now, let's remember what valence is. The valency of an atom is its ability to combine with other atoms. So, in this case, in the paper, for example, the terminology used is in a way kind of like the stickiness of points
Mhm.
where the nanoparticles can be attached to. Similarly to how, the valence of calcium and oxygen, the two can come together and they form calcium oxide as a stable compound because
Mhm.
of the unpaired electrons in their respective valence shells get paired up. And that equals happiness and
Mhm.
stability. So the nanoparticles in this work can adhere to different areas where they are programmed to be with the sticky ends of that DNA.
Yeah, so it's kind of like the blueprints that tell us the nanoparticles where to arrange themselves.
So in this case, the researchers designed a DNA mesh structure that acts as a frame. This DNA mesh has an icosahedral symmetry, and its symmetry is important to form a stable structure. So think of a shape with many triangles and many different sides.
Yeah, so that's like the soccer ball.
Oh, yeah, that's a great example. And these structures can have different valence modes for the attachments of the nanoparticles. For instance, two, three, four, or even more nanoparticles at predefined locations. Then these locations can form symmetrical or helical structures.
Right, so the gold nanoparticles attached through the frame through DNA binding. And I remember we've talked about DNA in our COVID episode 4, where we discussed about the mRNA vaccine. And as we know, the DNA is a double-stranded helix that contains the genetic code of life. And the code comes from different combinations of the building blocks called nucleotide. So if you have one strand of DNA, its complementary strand can bind to it.
Right. And in this case, the binding sites on the DNA mesh frame are called sticky ends, composed of six identical single-stranded DNA. By attaching the gold nanoparticles with the complementary DNA, they can bind to their programmed locations.
Yeah, and they successfully fabricated symmetric and helical structures with high accuracy when compared to the original design, as confirmed by the transmission electron microscopy (TEM) at room and cold or cryo temperatures, as well as small angle X-ray scattering. The locations, sizes, and the internanoparticle distances are very comparable to the symmetrical and helical designs. They also successfully fabricated DNA architectures with different sized gold nanoparticles attached to different DNA strands that were able to attach to the corresponding pre programmed sites on the frame.
Wow, that's amazing. And this is definitely a step forward towards maybe developing the Mark 50 Ironman suit.
Hmm.
But as of now, it requires lab controlled conditions in terms of solutions, time, and temperature. And the nanoparticles don't spontaneously appear like they do for the suit in the movies.
Yeah, but you know what? It's still a step forward. Maybe the
Sure.
suit will have DNA frames on them. And the idea is relatively simple, but the execution and technique is so beautifully done.
Yeah, I agree. Very true. And the link is in the description as always for more information on this research that was featured in the Journal of Nature Communications.
All right, everyone, that is all the Nano for today. Take care.
And stay curious.